exponential distribution. Should be a pretty quick section. Not really too concerned with you doing a lot of the solutions to these problems. It is important that you know, but way more important is that you understand how to set these ones up. Um, the exponential distribution is useful in certain applications, but it's not incredibly common. Um, but you want to know when to use it, why you use it, things like that. So their example here is, you usually use it when time is concerned, and when it's much more often that things occur quickly um, rather than longer time. Think about when there's like an inevitability. So because something hasn't happened, you're pretty sure it's going to happen pretty soon. Because you never go this long without rain, so it must be raining soon. Things like that. But what's this shape end up as? I think the best way to do this is just kind of walk through an example together. So here's the example. On average, a certain computer part lasts 10 years. The length of time the computer part lasts is exponentially distributed. So they tell you that it has an exponential distribution, so you know the shape. And this is one of the characteristics of this problem. It says that the mean is 10 years. This distribution is characterized by f of x. This intersection is going to equal 1 over the mean. That's just one of those things that you have to know. And then it follows an exponential distribution from there on out. And this question is saying, what's the probability that it lasts more than 7 years? Well, it's going to be anywhere in this range. This does go on infinitely small, but we do know that the sum of all this area is going to equal to 1. Like I said, I'm not going to ask you for that number. More just ask you how you get it, what's the range, what's the area that you should know, and setting it up. Next question is, on average, a certain computer part lasts 10 years. How long would 5 computer parts last if they are used one after another? So we do not know the answer to this question, but it's asking us what we expect, right? Well, we've talked about expectations. We expect the mean to be true. And well, they told us the mean is 10 years, and we are getting 5 of them, then our expectation is going to change, so we're going to expect each 5 to last 10 years. So we're going to assume that this will last 50 years. It's pretty straightforward. D here, what is the probability that a computer part lasts between 9 and 11 years? So take a second and think, what range are we going to be shading in our graph? And think about how big we expect this number to be. We expect it to be over 50%, under 50%. Yeah. All right, so we pull it up. Our shaded area is going to be equal to this section here, once again, between 9 and 11. And the area itself, once you calculate it out, is equal to 0.0737. So it's actually a pretty small chance that you're between 9 and 11, because there's an infinite number of possibilities. Now, like I said, we aren't going to get too far into actually calculating these, but I do want you to know that it is not incredibly difficult to do this. You would think it would be, because we're using a function and we're trying to find the area under a function, and that seems like pretty intense calculus. But exponential functions are known to be very easy to integrate, and that's what makes these problems pretty simple, actually. Just as an example here, I'll pull up, show you what this would look like if you were to calculate it out. This is the equation that gives us our 0.0737. Once again, that is just coming from this. So probability of x less than 11, so you're going area to the left, minus the probability x is less than 9. I hope you can see that that will give you this area. So it's this entire area minus this entire area gives you the purple area. And how do you find probability of x less than 11? We go 1, because we know all of this area under here is equal to 1, minus the exponential of negative 0.1 times 11. And the same for this, and that's going to give you 0.6671 minus 0.5534. That'll get you to your answer. Like I said, it's pretty simple in actual application. Just going to be e raised to the negative 0.1 times times 11 minus that. So once you get down to it, it's not horrible, but focus on the shape, focus on the regions you should know.